to another episode of MrLopezClasses.com. In this episode, we are going to continue with our course of Marine Intro for Marine Engineers. Okay, this chapter is dedicated to materials. The different type of materials that we are going to use in the construction of boats, in the reparation of boats. Yes, this is critical because the selection of the materials is vital in the construction and reparation of boats. A wrong decision about a material selected can destroy the boat. This is important because in the boat is submerged in water, salt water or fresh water, and additionally in the boat we have two different type of currents moving inside of the boat, flowing internally in the boat, DC current and AC current. This is the topic for our next coming class, the electrical class. Yes, we have currents and we have a marine environment. This is not good because we have a salt water, good conductor of electricity, in combination with flow of electricity, with currents draining through the metals. And this is the worst scenario for us to accelerate the corrosion and to destroy metals or materials if the material is not appropriated for the construction of boats. For that reason, this episode, this chapter is important in your career. I want that you pay a lot of attention in the details that I am going to give in this episode. I am going to start the majority of my books talking about this topic, about the materials. The electrical class starts with a similar chapter talking about the materials in order to select the proper conductors or isolators for electricity. In the course of corrosion, I start with this topic, of course, because in the corrosion we are going to analyze what happened with the corrosion in this marine environment. And of course, the selection of the material is vital, is important. And yes, the majority of my books, I start talking about the materials because depending on the topic, the materials are critical. The selection of the material is important. Okay, we are going to start with the material that we are going to use in general in the construction and reparation of boats. We are going to use wood, different type of woods. Chapter by chapter, we are going to analyze different type of woods depending of the system and depending if the system is in contact with the salt water or is isolated. Wood is, in my opinion, the number one. We are going to use different type of woods. All the woods should be marine approved, no generic woods, because you introduce another additional problem in the boat. Composite materials, yes, we are going to use a lot of fiberglass. We are going to use a lot of carbon fiber and other additional new generation composite materials that are very, very common every day in this business, in the marine industry. And we are going to use metals, different type of metals and alloys. For that reason, we are going to divide the alloys in ferrous alloys and non-ferrous alloys. Yes, the ferrous alloys based on iron, and the non-ferrous alloys based in non-ferrous metals like copper, aluminum, magnesium. All of those are non-ferrous metals. Yes, the alloys are important. We are going to study the different type of alloys authorized, approved for marine environments, and alloys that are widely recognized, that are excellent to avoid corrosion. And at the end, we are going to check polymers and ceramics. Every day the synthetic materials grow faster, and we are going to study that there are polymers with a tensile strength superior than steel, nylon. Yeah, a lot of composite materials, a lot of metals, a lot of wood, we are going to analyze in this particular class. Okay, we are going to start with the basic, with the fundamentals of all of those type of material is matter. The nature of matter. What is the meaning of that? What is the meaning of nature of matter? All the matter is made of atoms, and each atom internally is composed is composed of protons, positive charge, electrons, negative charge, and neutrons, neutral charge. Yes, the atom in the center is composed of protons and neutrons, and the orbits are with electrons. Each atom by itself is considered that is stable, is neutral. Each atom. What is the meaning of that? Each atom have the same amount of protons in the nucleus than electrons in the orbits. Yes, in all the atoms, the amount of protons and the amount of electrons are equals. Yeah, each atom have the same amount of protons and electrons. Most atoms have approximated the same number of neutrons and protons and electrons, but it's not exactly the same amount of neutrons. Some materials, some elements have a little more amount of neutrons in the nucleus. Remember that the neutrons, the charge is neutral. For that reason, the neutrons no affect the charge of the system, only affect the weight of the atom. Yes, there are atoms that we are going to analyze right now. They have more neutrons than protons in the nucleus. Those atoms are heavy atoms in comparison with other ones. In general terms, in the nucleus you have similar amount of neutrons and protons, normally a little more neutrons than protons. But the number of protons and electrons are exactly the same. The number of protons and electrons should be exactly the same. Okay, and we are going to analyze the nomenclature about the atom. The top number here, this is the atomic number. The atomic number of an element refers to the number of protons or electrons in each atom. Remember that each atom has the same amount of protons and electrons. The atomic number refers to that number, the number of electrons. Okay, what is the meaning of that? For example, barium have 5 electrons in total. Nice. Or 5 protons in total. What about aluminum? Aluminum have 13 electrons in total or 13 protons in total. This is the atomic number. Okay. Other important number is the atomic mass. The atomic mass or atomic weight, depending, each book refers different, of an atom is determined by the number of protons and neutrons in the nucleus. Let me explain what is the meaning of that. For example, we are going to check lithium. Lithium, the atomic number of lithium is 3. However, the atomic weight of lithium is 6.9. What is the meaning of that? That in the nucleus there are a little more amount of neutrons than protons. For that reason, the weight is a little higher. Okay? The atomic weight is the number located in the bottom, indicate the amount of neutrons and protons in the nucleus. Yeah? For that reason, the atomic weight in the bottom is a little more than double of the atomic number. That's clear? That's the reason. Okay, other important consideration is the valence electrons. What is the meaning of that? Those are the electrons located in the last orbit of each atom. Those are the valence electrons. Those electrons located in the last orbit are critical, are important in order to classify the elements in the periodic table. The classification of the elements in the periodic table is according with the amounts of electrons of each element in the last orbit. Remember, all the atoms by itself, they have the same amount of electrons and protons. The electrons are located in each atom in different orbits. If you see in this particular example, there are some amount of electrons in the last orbit, other amount of electrons in the previous orbit, and other amount of electrons in the previous of the previous. For example, in this particular example, I think that this is aluminum. Aluminum have in total 13 amount of electrons. Okay. Where is located? Let me check. Aluminum have 13 electrons in total. In the last orbit, aluminum only have 3. Where are located the other 10 electrons? In the previous orbits. Okay. Let me explain something about the organization of the periodic table. The periodic table is organized in groups, vertical groups. Look at the denomination of the groups. This is the group number 1. This is the group number 2. Now I am going to jump it into the group number 3, number 4, number 5, number 6, number 7, and number 8. The elements located here in this section are considered transition metals, and they have a special consideration that I am going to explain in a couple of minutes. There are 8 main groups. Group 1, 2, 3, 4, 5, 6, 7, and 8. Those are the principal groups. The elements located in the group number 1, they have only 1 electron in the last orbit. The elements located in the group number 2, they have 2 electrons in the last orbit. The element located in the group number 3, they have 3 electrons in the last orbit. And the elements located in the group number 8, they have 8 electrons in the last orbit. When the atoms try to combine with other atoms, produce molecules. We are going to study later that. All the molecules try to be stable. What is the meaning of that? Each atom during the process of combination with other atoms, each atom try to complete in the last orbit 8 electrons or 0 to be stable. Each atom by itself is stable. But when the atom tries to combine with other ones, the atom tries to keep in the last orbit 8 electrons or 0. 8 electrons or 0. What is the name of that rule? This is the octet rule. This is the octet rule. All the atoms want to have 8 or 0 electrons in the last orbit. Okay? We are going to talk later about that. This is the octet rule. Alright, my friends. We are going to continue about the process of organization of the periodic table. The elements are organized in groups according with the amount of electrons in the last orbit. Let me analyze this situation. In the group number 1, hydrogen is the element number 1. How many electrons in total have hydrogen? 1. For that reason is located in the group number 1. How many electrons in total have sodium? In total, 11. But in the last orbit, only 1. Where are the other 10 additional electrons of the sodium in previous orbits? But in the last one, only have 1. Exactly the same like all of those elements, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, all of them, they have in the last orbit 1 electron. Doesn't matter if they have more before. For example, cesium have 1 electron in the last orbit and 54 additional electrons in previous orbits. A lot. Okay, let me check in group number 2. Group number 2, beryllium, magnesium, calcium, strontium, barium, and radium. Those elements located in the group number 2. They only have 2 electrons in the last orbit. What about calcium? Calcium in total have 20. 2 in the last orbit and 18 in previous orbits. That's clear? Aluminum. Aluminum is located in the group number 3. Aluminum. How many electrons in the last orbit? 3. And how many electrons in previous orbits? 10 additional electrons. It's located in group number 3 because have 3 electrons in the last orbit. You like it? That's perfect, no? This is aluminum. What about the fluorine and chlorine? Those elements, located over there. They have 7 electrons in the last orbit. Fluorine, chlorine, bromine, iodine, astatum. All of those elements in the group number 7, they have 7 electrons in the last orbit. What about the group number 6? Oxygen, sulfur, selenium, tellurium, polonium. Those elements have 6 electrons in the last orbit. Yes, sulfur have 6 electrons in the last orbit. But in total, sulfur have 16 electrons. 6 in the last orbit and 10 in previous orbits. Okay. The groups are organized according with the amount of electrons in the last orbit. Those lines, the horizontal lines, are the periods. Each row is called a period. All the elements in a period have the same amount of orbits. What is the meaning of that? The elements located here and here, hydrogen and helium, they have only 1 orbit. The elements located in the second one, this, they have 2 orbits. According with this is the amount of orbits. Let me check. Aluminum have 3 orbits. Aluminum have in the last orbit 3 electrons and 10 in the previous 2 additional orbits. Yeah? 1 orbit, 2, 3, 4, 5, 6, 7 orbits. The maximum amount of orbits per each atoms is 7. 7 orbits. Okay? This is the organization. Dmitriev, Mendeleev, that guy, organized the periodic table according with those parameters, with the amount of electrons in the last orbit and with the amount of orbits. Okay, my friends, let me explain something. Now we are going to try to understand one important concept. That important concept is about the electronegativity. What is the meaning of electronegativity? But I want that you understand the electronegativity in a simple way. Exactly like I want in all my books, in all my courses, that you understand in a simple way. No complicated way, simple. Because if you want to be an engineer, you need to be practical, simple. Okay, my friends. Suppose this situation. You have a mom with 1 kid. A mom with 1 kid in the mall, in the supermarket, with only 1 kid. It's easy for the mom, I want ice cream. Okay, no ice cream for today, bye-bye, tata. It's simple, administrate 1 kid. What about the same mom with 2 kids in the mall? It's a little more complicated. The mom needs a little more energy with 2 kids. Can you imagine the same mom with 3 kids in the mall? That mom requires more energy to administrate 3 kids. Can you imagine a lady in the minivan with 7 kids? Hey, close the window! No, open the door! Hey! That's impossible. How much energy need the mom with 7 kids in the minivan. A lot of energy. The moms with 7 kids in the last orbit, those moms have too much energy. The moms with only 1 kid in the last orbit, they are lazy moms. They don't need too much energy because it's easy with only 1. But with 7, with 6, that's too much. The elements located in the groups numbers 5, 6, and 7 in this corner, those elements have too much energy. High level of energy. And the elements located in the groups 1 and 2, especially in the bottom, those elements have low level of energy. The amount of energy of each element by itself, this is the electronegativity. Let me I explain something. You know this? You know this? This is the salt to prepare food. This is the salt that you use every day. What is the formula for the salt? It's that one. It's sodium and chlorine. It's sodium and chlorine. This is a molecule. Salt is a molecule. Sodium and chlorine. How many electrons have sodium in the last orbit? Sodium in the last orbit, only 1 electron. How many electrons have chlorine in the last orbit? 7. What happens if sodium is close to chlorine? They can connect together? Yes, and they produce the molecule of salt, sodium and chlorine. What element have more energy? Sodium or chlorine? Chlorine, because chlorine is located in the group number 7. Chlorine have 7 electrons in the last orbit. How many electrons need chlorine to be stable? 1 more. And what about sodium? Sodium have too much energy? No, low level of energy. Sodium release that electron, chlorine absorb the electron. At the end of the day, chlorine have 8 electrons in the last orbit, sodium 0, and the molecule is stable. This is a perfect molecule, the molecule of salt, because when they are together, chlorine complete 8 in the last orbit, octet rule, and sodium 0. This is a perfect molecule. Yeah, this is a good combination. The element with higher electronegativity try to absorb electrons, and the elements with lower electronegativity try to release electrons when they combine to create molecules and compounds. Alright? The element with higher electronegativity try to absorb electrons from the element with lower electronegativity, with lower level of energy. This is the definition of electronegativity, is the amount of energy of each atom. There are elements with higher electronegativity located in this area, in the upper right corner. And there are elements with lower electronegativity located in the lower left corner, in this corner. For that reason, in the periodic table, the element with the lower electronegativity in the periodic table is francium. Francium only have 0.7 millivolts of energy, and fluorine have 4 millivolts of energy. More energy fluorine. Those 3 elements, oxygen, fluorine, and chlorine, they have the highest electronegativity in the periodic table. And those 3 elements attack the rest of the elements in the environment. Yes, my friend, for that reason, oxygen oxidizes everything, because oxygen only have 6 electrons in the last orbit. Oxygen only need 2 additional electrons to be stable. For that reason, oxygen is checking in the environment other pieces of metals to attack those metals, subtract those 2 additional electrons and be stable. Yes, my friends, for that reason, the oxygen attack the rest of the metals. The same with fluorine and chlorine. Yes, fluorine and chlorine in the environments are no good. Where you found that high concentration of fluorine? Where you found that high concentration of fluorine? Where? In the cans with the sprays, like paint in a spray, deodorants in a spray. All the sprays, they have too much fluorine because the fluorine have the ability to pressurize. The manufacturer use fluorine to pressurize the liquid to be sprayed. For that reason, the rest of the countries, they say, please don't use sprays. Don't use deodorant in a spray. Use deodorant in bar or in ball. Avoid sprays because when you apply the nozzle on the spray, you release fluorine into the environment, and that fluorine with only 7 electrons in the last orbit try to get the additional electron from the oxygen, destroy the oxygen, the O2, and attack everything. This is not good for the environment. In the aerosols, you found a lot of fluorine, and also in the refrigerant of the air-conditioned equipment. The formula for the refrigerant is this. This is the formula. Fluorocarbons, fluorine, a lot of fluorine. For that reason, recover the refrigerant in air-conditioned equipment is a special process, is a special procedure. We are going to study that procedure in detail in our book of air-conditioned system. Yes, my friend, be careful when you release refrigerants into the environment because you destroy the molecules of oxygen. Let me analyze that molecule, the molecule of oxygen. How many electrons have oxygen in the last orbit? Oxygen only have 6 electrons in the last orbit. Oxygen alone, only one molecule, or only one atom of oxygen. But in the environment, you found that the oxygen single. The oxygen that you breathe is single oxygen or O2? Is O2. Why? Because O2 is stable. Let me analyze why. Oxygen with a 6 electron in the last orbit, and other oxygen with 6 electron in the last orbit. How many electrons need oxygen to be stable? Need 2 additionals. Oh, they can share 2, both of them, and right now both of them, they have A and A. That molecule is an stable molecule. That relation that they share momentarily, the electron is covalent. And the previous one on the salt is permanent, is ionic. When the relation is permanent, it's difficult to separate, is ionic. When the relation is like this, covalent, is simple. In this case, the oxygen is a molecule with 2 identical atoms. That relation is a covalent reaction. Is covalent, is non-permanent in comparison with the previous one, with the salt, sodium and chlorine. This is permanent because one element have higher energy in comparison with the other one. This is ionic relation, and the other one is covalent reaction. Give me an example of other perfect molecule in the environment. Yes, the molecule of water. What is the formula for water? Is H2O. What is the element with more energy in that formula? It's the oxygen, with 6 electrons in the last orbit, 5 and 6 electrons in the last orbit. And the hydrogens, 1 in each side, with 1 electron in the last orbit, in the last orbit and less energy. Okay? The element with more energy absorbs the electrons from the hydrogens, and the oxygen complete a electron in the last orbit, and each hydrogen 0 and 0. And this is another perfect molecule, the molecule of water, stable. For that reason, the water no react. The water is stable, no react. This is another great example of a perfect molecules. And now we are going to start in the next episode with the classification of the materials that we are going to use to fabricate boats.